Good morning, students. So, in the last class, we have concluded collections and have given introduction to multi-threading, and we are supposed to complete this multi-threading concepts today. And today, I'll just demonstrate you the two different ways of creating threads. That is, extending thread class and implementing runnable interface. And then we will look at few thread control mechanisms, and also we will understand the use of thread priorities and thread synchronization. And yesterday I have already discussed why do we require to go for multi-threading, and I have also given brief about the difference between process-based multitasking and thread-based multitasking. So process-based multitasking is basically running more than one program concurrently, whereas thread-based multitasking is about running single program concurrently. That means parts of the program will be executed concurrently. This will improve the throughput and also CPU utilization. And thread based multitasking results in high performance. So, for that reason, it's very essential to go for multi threaded applications where your single application will be divided into several threads that run concurrently. And you might have remembered the different states that a thread can be in, I mean the thread life cycle. But just to reiterate, so we have five states where a thread can be in. Whatever the process states you might have studied, they are same with respect to the thread states also, but still let's reiterate the different thread states. So a thread can be in one single state at any point of time. It cannot be in more than one state. It can be in any one state at any point of time. And the different thread states are born state, ready state, running or active. Either of the term it's fine. Running or active state, and next sleeping or waiting or blocked. You can use any of these three terms: sleeping or waiting or blocked state. And lastly, the dead or terminated state. So these are the five states where a thread can be in. And as I said, at any point of time, a thread can be in one single state only. All the newly created threads are said to be in born state. And if a thread is in born state, it's not available in the main memory. It's still waiting for its turn to get inside the main memory. And if a thread is invoked start, then it is said to be occupied in the main memory. And all the threads that are ready for execution will be coming into the ready state. And once the CPU decides for a thread to be executed, then the thread is said to be in running or active state. And suppose a thread invokes a sleep method, or it invokes some IO operation, or it will be suspended for some other event to take place, then the thread will move from this running state to the blocked state. And once the IO operation for which the thread is suspended, or the event for which the thread was waiting, if it is ready, then again the thread will be moved to ready state, because by the time when it was waiting for the event to happen, that is in the blocked state, the CPU might have scheduled another thread for execution on the running state. That's the reason any thread which is in blocked state, if its IO operation is ready, or if its sleep is over, or if it is notified by some other thread, or if the event for which it was waiting is over, then again the thread comes back to ready state but not to the running state directly. And once the thread task is completed, I mean whatever the task assigned for a thread is over, then it moves to dead state. That's the terminated state, by just reporting to the calling thread that the task it was assigned is accomplished. So that's how the thread will be moving across these states, and the thread will be moving among these three states primarily, that is between ready to running, running to blocked, blocked to ready. So in this circle mostly the thread will be spending its time. So that's what about the thread states. And how do you create threads in Java is using two ways. The first approach is by implementing runnable interface, and the second approach is by extending thread class. Among these two, the simplest way to create a thread is by implementing the runnable interface. So, and generally we will be going for extending a class only when you want to have some additional behaviors to the existing. Other than that, if your intention is only to create an entry point for the thread to execute, then it's always recommended to go for the simplest mechanism, that is implement the runnable interface. So even as per the industry standards, most of the times you will be creating threads by implementing runnable interface than compared to extending thread class. This point need to be remembered. As per industry standards also, most of the times we will be creating threads by implementing runnable interface than compared to extending thread class, because we will be creating threads and our intention is mainly to create an entry point for the thread to begin. And this runnable interface has only one single method to be implemented, that is public void run. So there's only one method that you need to implement by implementing this runnable interface, that is public void run. And this public void run method is the entry point for any thread to begin its execution. And from this run method you can even call other methods just like how you call from the main method, because we know that main is the starting point for the program execution, and from main only you start creating objects, you start calling other methods from other classes, and that's how you will be doing. In similar fashion, when you create a thread and you require an entry point for the thread to begin its execution, and that entry point is going to be the run method. So all that you want to do when the thread begins its execution, you are going to place that code in the run method. And as I said, from this run you can even call other methods just like how you do from main. And we don't directly call run method, we have to just invoke the start method, because as I said, the CPU scheduler will decide when your thread must be given chance for running. Until that, you can only invoke start method saying that my thread is ready for execution. And whenever CPU scheduler finds that your thread can be scheduled to the running state, then automatically your thread will be moved from ready state to running state. So that's what you need to understand, that we will not be calling run directly. We just invoke start method, which in turn calls the run method. We will be calling start, which in turn calls the run method. And start, you will not be defining any body. Only for run, you will define body. Start is just a method call, which in turn calls the run definition. So this is the point you just need to remember. And as I said, the easiest way to create threads is by implementing runnable, and this runnable in turn abstracts the unit of executable code, and we just need to override one single method, that is public void run, which is the entry point for the thread, from which you can call other methods, just like how you will be calling from the main method. And also remember the fact that even main itself is the thread. So even though so far we are not creating any threads, but you need to understand that the very first thread that gets executed is the main thread. Main itself is a thread. The very first thread that gets executed for any application is the main thread. This is the answer you should remember. The very first thread that gets invoked, it will be the main thread always. So now let's see with a program how we are going to create threads by implementing runnable interface, and the same program I am going to modify to do the same by extending thread class. So first we will see with runnable interface, and later the same code I will just modify to make it by extending thread class, and we see how threads get executed, and we also see other thread methods, how we can use it, because from runnable you can't use any other methods, because it's only an interface which has only one abstract method, that is the public void run method, which we will be overriding for creating any thread. Okay, let's create a runnable demo. So I'm just naming this program as runnable demo, and then let's also include main method. So before this runnable demo and creating another threads, let's create a class, and for this class I'm just declaring a variable of thread type, and this thread class is belonging to lang package only. That's the reason when I'm writing directly thread t, it's not giving any error and not giving me any fixes asking me to import so and so package, because thread class belongs to the lang package, which is the default package that gets added to each and every application. So I'm defining my own constructor. So I'm just invoking thread constructor for creating a new thread, and you can even give name to this thread. You can give any name to this thread. So just understand, this nothing to do with other than giving our own name. Okay, here I am writing this new thread like this, but I haven't implemented runnable interface. So we have to implement runnable interface, then only you can create the thread with runnable. So implements runnable. So now you can see it's gone, and the other error it's expected. We need to override that runnable interface method, which is nothing but the run method. So this is how you can just ignore all the errors. And now I have set my own name to this thread, and we have already understood the use of this in previous sessions. This refers to the current invoking object, so that's what here this is meant for. Now in order to understand, I'm just including a print statement, and here I'll just call the thread object itself, and then we need to start this thread. So as I said, in order to start, you have to use the method start, and this start in turn invokes the run method. So in the run you have to write your code. So I'm using try catch. I'll tell why I'm using this try catch. So I'm going to create multiple threads. In order to understand how those multiple threads will be invoked, I'm just using a sleep method, and this sleep method in turn is of the thread class, which will be throwing interrupted exception. So let's just display the variable itself, and now what I'll do is I'll just invoke the sleep method. Here you can see sleep method will take one argument, that is long milliseconds. So I'm just going to give some 500 milliseconds, and here you can see now try. So this sleep method, here you can see the signature, the sleep method signature you can see here, void java.lang.thread.sleep throws interrupted exception. And when we have discussed about exception handling, I have said the usage of throws. So if any method is having this declaration throws so and so exception, what does it mean? So that method, whoever is going to call, it is their responsibility to handle that type of exception. So here I'm just making use of sleep method of thread class, and that thread class sleep method is having the declaration like this. As you can see here, void java.lang.thread.sleep long millisecond throws interrupted exception. And since I am calling this sleep method of thread class, so it's my responsibility to catch this particular exception, that is interrupted exception. So for that reason I have written this try, and now I am going to handle that by using catch interrupted exception. Generally we won't get any interruption, but still it is our responsibility to handle this interrupted exception, since I am calling the sleep method which has the declaration throws. So I'm just displaying if it comes interrupted. That's the only message I'll write, because as I said, it won't be raising any interruption, but still I'm just writing that. And then, so this is the end of the catch. And now what we just display is just for understanding that this is completed. So I'll just write sys out child terminated. Simple message just to understand that child terminated. And then, yeah, I think this is fine. So here you can see what we have done. So we have just created a thread1 class that implements runnable. Just make sure that you don't use the same class name thread class, which is of the lang package. So that's the reason I have just used thread1. Don't get confused. So thread1 implements runnable, and I have defined my own constructor, and I'm just creating a new thread with the name set to the runnable demo. We will see few more methods, don't worry. And then I'm just displaying a message, because if I don't write the system.out.println, you don't get to see anything difference. So for that I'm just using, and then I have invoked the start method. So start will in turn call the run. So even though you are calling start, you are not going to define any start. I mean, you don't write body for any start method, you just write body for the run method. And this run method which we are doing is an overriding. Here you can see it's an overridden method that is as part of implementing the runnable interface. And in this we are just creating few more threads, and just to understand that which is being called, and for that we are just calling the sleep method, which is again from the thread class, which has the declaration throws interrupted exception. So for that reason I am just handling this interrupted exception if it is caught. Then I'm just displaying simple message interrupted. And then yeah, out of this method I'm just saying child terminated. And within this runnable demo, now what we do is we just call the thread from this main thread. As I said, main is also another thread, which is the very first thread that gets invoked as part of execution of any program. And from this main thread, what we are going to do is we are going to invoke the constructor. I'm just invoking the constructor. And here, just to understand that again that's a child thread and this is main thread, what I'll be doing is I'll just copy this same code. So, and then I'll just paste it here. And here what I'll be doing is, here instead of writing child, I'll just write this as main. And if it gets interrupted, just to understand, I'll just write main interrupted. And here I'll just write main terminated. And in order to have the difference, I'll just change this time to 1000. So child will be invoked for every 500 milliseconds, whereas main will be invoked for every 1000 milliseconds. Just to understand the differences, I am just modifying like this. And now main need not be called as start, because by default main will be the starting thread. Let's run this and see how things will happen. So here you can see how it is being displayed. So this is the output we are getting. Just understand from the output what was happening actually. So we know that main is the very first thread that gets invoked, and from the main, the very first statement what we have done is we have called the thread1 class constructor. And in the thread1 class constructor, what I have done, I have just created a thread, and then I have called child, and then thread we have printed the thread object itself, and the thread object is displaying. Here you can see this is the name of the thread, and this is the priority of the thread, and this is the thread group. So thread group by default it's main group, since we haven't created any thread group, so it is displaying me the thread group name as main. So when you print the thread object itself, these are the three values it is returning. The first one is the name of the thread, the second one is the priority of the thread, and the third one is the thread group for which this particular thread belongs to. So that's how you are getting this output. So child colon, which is that we have given here. Here you can see, sorry, here child colon and then t. So this t is the thread object you are printing, and this runnable demo is the name which you have given to your thread. So that's why you are getting this name runnable demo as the thread name. And priority you haven't set, but By default, every thread will be having some or the other priority, and if no priority was set by you, by default it will be getting the priority of the parent thread. I mean, the one which is calling that thread's priority, it will be getting. And this child thread is being called by whom? Main. This child thread is being called by whom? Main. So it will be acquiring the priority of the main thread. And did we create any priority to the main thread? No. So by default, the main thread will be having the normal priority. And since we got this point, let me just tell you here, thread priorities can be either minimum priority or the normal priority or the maximum priority. So a thread priority can be either minimum, normal or maximum, where minimum priority of the thread is 1, normal priority of the thread is 5, maximum priority of the thread is 10. So each and every thread will be having some priority which ranges between 1 to 10, and it has to be an integer value. You can't have a what do you say, real value for any thread priority. So every thread can have a priority which ranges between 1 to 10 of integer value, and if it is 1, we say that the thread is having the min priority. If it is 10, we say that the thread is having the max priority. If it is 5, we say that the thread is having norm priority. So by default, when you don't assign any priority to a thread, the thread will be acquiring, or you can say inheriting, the priority of the thread which it is calling. Right now, my child thread is called from main thread. So main thread's priority will be inherited to my child thread. And since we are not assigning any priority to my main thread will be always having the normal priority, which is nothing but the 5. So the same priority is being inherited by my child thread. So that's how you can see here 5. So child, thread object, name of the thread, priority of the thread, thread group for which this particular child thread belongs to, which is the main group. And then here you must understand the difference. So main thread I am displaying 5 values, child thread I am displaying 5 values, and here you can see main, when it have printed first value, it have gone to sleep for 1000 milliseconds. It have gone to sleep for 1000 milliseconds. So that's the reason child thread is being invoked, and child after printing 1, it have gone to sleep for 500 milliseconds. So since it have gone for 500 milliseconds, main has to be scheduled, but still main is not yet awake because it went to sleep for 1000 milliseconds. So by the time child will complete its 500 milliseconds and it got awake, and it have printed the second value. So after printing second value, child will again go to sleep for 500 more milliseconds. So that's the reason after two values of child are printed, main is again ready. That means main completed its 1000 milliseconds. So that's the reason here you can see main being coming into picture, and after main printed, again child comes into picture twice, because main is going to sleep for 1000 milliseconds, where the child will sleep only for 500 milliseconds after each invocation. So just to make you understand that difference, I have just used a sleep method, and with varied values for both child and main. And here next main 3 and then child 5, and you can see child got terminated because child is completed its task, that is printing of 5 values. So it got terminated, after which you can see main is completing its task and getting terminated. So this is how the program is functioning. I hope everyone understood this point. And as I said, here thread communication is happening with the sleep method. Uh, the inter-thread communication in Java can be achieved with the use of three methods: wait, notify, notify all. These are the three methods we will be using in Java in order to achieve thread communication. So wait method will be executed by a thread, and it will go to indefinite blocking until it is being notified by some other thread. So notify and notify all, these are the two other methods which are used by the thread in order to notify a particular thread which has gone by executing wait. Notify all is used to invoke or give notification to all the threads that are been waiting. So that's the basic difference between notify and notify all. Now what we will do is, let us modify the same code with the use of extending thread class. So instead of implements, what I'll do is I'll just modify little, and when you say extends, compulsory you need to have a class name. So here you can see what I have done. So just observe the minor differences what I am doing. So the same class name extends thread class. Instead of implementing runnable interface, I am extending thread class. So instead of calling this, what I will be doing is I will directly call the super. I'll directly call the super, and here I'll write there we have written runnable demo na. Here I'll just write thread demo. I'm just calling the super, and we know the use of super also. Very minor changes. Okay, now see what are the simple changes I have done. So here what I am doing is, instead of implementing runnable interface, I have just extended the thread class. I have just extended the thread class, and since I am extending the thread class, I am invoking the thread class constructor directly. I am invoking the thread class constructor directly by using the super. Here when I am moving my mouse cursor over there, there you can see which constructor is being invoked there. There you can see java dot lang dot thread dot thread constructor, which is taking string argument, which is taking the string argument. That's the constructor we are calling actually. So by super of thread demo, what I'm actually calling is, I'm calling the thread constructor by giving the name to my thread. I'm calling the thread constructor, that is from the thread class, by giving the name to my thread. And here when I am saying this, in previous case what we have written, this t object I have printed, because that's the object which I have created for my thread. Now I am directly invoking my thread class constructor by invoking this super. So I am directly saying this, that means current invoking object. And then since you are directly invoking the super constructor, you don't require to tell anything, directly you can call start method like this. No need any object. We have already discussed, whether you pass it or not, by default every constructor and every method will be getting this argument as default. This is nothing but actually what you see here start, it's nothing but this dot start. Even though we don't see it there, but you have to understand that it is like this dot start, and this refers to current invoking object. And now you can see when I moved my mouse cursor over there, what it is telling, void java dot lang dot thread dot start. It's nothing but thread dot start. And again let's save this. You don't find any difference except the thread name. Only the thread name I have changed. Other than that you don't see any difference in the output. So here you can see, so yeah, it's completed. Here you can see the thread name thread demo. Rest everything output will be the same, because I haven't modified the code much. Only thing I just modified is, rather than implementing runnable interface, I just modified it to extend thread class, and rather than creating a new thread object with using a thread t equal to new thread like this, directly I am invoking my thread constructor with the use of super and giving the name to my thread, and I'm just using this, which refers to the current invoking object. And to call start also I don't require any object, because by default we know that this will be passed as an argument to every method and every constructor. You don't see it, that's it. But compiler by default pass this as the argument to every method and constructor. So here, even though you don't see anything, when I'm calling start, it's nothing but this dot start, and this refers to current invoking object which will be substituted by the compiler at the time of execution. So this is how you are just invoking this program. And now let us understand few terminologies here. First thing you need to observe is the giving name to a thread, and you can even get this name itself printed by using okay, yeah, current name. So here we can just use this thread dot. Here you can see what are the different arguments you can give. Here I am using thread dot current thread. I hope you can see. Here I am invoking thread dot current thread. So you can just use this. This is how you can even retrieve the name. So here you can see current name. This is also the other way of retrieving, and here you can see main is the one which is calling this particular thing, how it is being called. That's current thread which is saying main. When you are seeing thread dot current thread, you can see, and even you can give dot, and here you can see get name. Rather than getting all the fields, you can even just use get name. I mean, field by field also you can just acquire. That's what I'm trying to tell. And here you can see current name main, and similarly you can even acquire property itself. I hope you have observed when I have just given dot, and it have listed me all the things which you can get from that. Get name, get priority, like that you can just get all the information. And here you can see active count. So here you can see how many are active. Like that you can just get all the information by using this thread dot current thread. So it is used to get the current info, that is the thread information can be acquired by using this. And even you can set your own name to the threads also. I think you understood this by seeing here. Now next thing you need to understand is how many types of threads will be there. In general, there will be two types of threads, and whatever the threads now we just created come under the category of user threads, and there is another way of creating threads, that is daemon threads. There are two types of threads basically, user threads and daemon threads. So user threads are those which will be running in the foreground, whereas the daemon threads are those which will be running in the background. And the best example daemon thread even now that gets running is the garbage collector. So the best daemon thread that we can take as example even now as part of our use of this Eclipse IDE is the garbage collector. So when you are creating your Java applications, the continuous daemon thread that will be always alive is garbage collector, because garbage collector will be running in the background, which will be periodically verifying for the unused objects, and it starts erasing them from the heap memory. So it won't be seen in the foreground, but it will be running in the background, and in the foreground your user threads will be performing the task assigned by your application. So just one thing you remember, so there will be two types of threads, user threads and daemon threads. So daemon threads are those which will be running in the background, and user threads are those which will be running in the foreground as part of the application. And daemon threads will be always having the lowest priority. Daemon threads will be having always the lowest priority, where your user threads will be having priority ranging from normal to maximum. I repeat, always the daemon threads which will be running in the background will be having the priority very low. That's nothing but the minimum priority. Whereas the user threads which has to be run in the foreground will be having priority ranging from normal to maximum. Since we are discussing about thread priorities, first let us understand what these priorities are meant for. So I already stated just before that a thread priority is an integer value which can range between 1 to 10. And why do you require this thread priority? The first question that arises is, why do you require this thread priorities? So basically, a higher priority thread will not execute faster than a lower priority thread. It only gets more time than compared to a lower priority thread. So this is the point need to be understood. So don't just feel that if a priority of a thread is high or max, that will not be running very fast than compared to low priority thread. Only thing is it will be getting more time than compared to the time given for a low priority thread. And another thing also need to be understood is when there in, there is a context switch that has to be taken place, when there has to be a context switch that has to take place, then there may be several threads waiting for CPU. Among them, which thread should be given chance for getting executed? At the time, this thread priority comes into picture. So among several waiting threads, the one which has higher priority will be first getting chance to be executed by the CPU. This is where the thread priority comes into picture. So whenever there are multiple threads that are waiting for their turn to be executed on CPU, then whenever the current thread is going from running state to blocked state, that is, it might be voluntarily, I mean, it might require some IO operation, or it might have executed some wait operation, or it might have executed some sleep operation voluntarily. That's what I mean to say. So if the current executing thread wishes to move from running to waiting voluntarily, then one of the thread from the ready state should be chosen for executing. Then which thread will be chosen is dependent on this priority value. So the one which has higher priority will be given first chance to be executed by the CPU. Now another question also arises. What if there are multiple threads with same priority? This is also another question, because we understood the point that the higher priority thread will be given first chance to be executed by CPU. But the immediate question that gets into our mind is, what if we have multiple threads having the same priority, that is the higher priority? Then which has to be given chance first to be executed by CPU? It's very simple. In Windows like operating system, it uses the round robin scheduling fashion, where equal time slice will be given in the order which they are waiting in the ready queue. They will be scheduled in the time slice fashion. That means, suppose if there are two threads having the same high priority, then the one which is standing in the first in the queue will be given some 3 seconds, say just let us say 3 seconds, and after 3 seconds again it will be moved back to ready state, and the second high priority thread also will be given 3 seconds, like this in a round robin fashion, like this in a round robin fashion. So each and every thread which are having same priority will be scheduled round robin fashion in Windows operating system. Similarly, each and every operating system will have their own scheduling policy when you have multiple threads competing for CPU which are having same priority. But Windows and Solaris are the two operating systems which uses this round robin time slicing, that is equal amount of time will be given for each and every equal priority threads. So this is the point you need to understand. And there is also another occasion where the high priority thread might also forcefully suspend the one which is ongoing. It if it is low priority thread, it will suspend it, and then it will be acquiring the CPU for execution. And this we call it as preemptive multitasking. And this is what we call it as preemptive multitasking. So as I said in the earlier case, if a current ongoing thread is voluntarily wishing to move from running state to blocked state, then the high priority thread will be given chance to be executed by CPU. This is the first scenario where everything is going smoothly. But in the second scenario, which I just stated now, when a high priority thread arrives, then the current ongoing thread, which is having low priority, might also be forcefully suspended and moved to blocked state, and this high priority thread might be given chance to be executed by CPU. And this we call it as preemptive multitasking. And this we call it as the preemptive multitasking. So this is what you just need to remember as part of the thread priorities. So always remember that thread priority doesn't state that higher priority thread will be executing faster than it is supposed to. No, the speed of execution will not vary. It's only the amount of time dedicated for the high priority thread will vary. That's the point to be noted. And as I said, threads are of two types: user threads and daemon threads. Daemon threads are those which run in the background, giving preference to the foreground running threads, and foreground running threads we call them as user threads. And user threads will always have the priority ranging between 5 to 10, whereas the daemon threads will always have the low priority. So these are the main points you just need to remember. And by default, each and every thread when created, it will be inheriting the priority from its parent thread. I mean parent thread in the sense the one which is calling it. So whichever thread calls this another thread, that another thread will inherit the priority of the calling thread. This is the point you just need to remember. And we have two methods for getting the priority value or for setting the priority value. So you can use the methods something like okay, let me create another class, that will be better. So I'll just use the name thread demo, and let's create main also for us. Let's remove this to do stub code, and then here what we do is, let us just create a simple thread t equal to thread dot. Okay, let me just use the current thread, which we know that main thread is the current thread, because I am not creating any other threads. So main thread is going to be my current thread, obviously. So let's just check it by using that this t dot. Okay, let me just get the name. Okay, let's just first understand Okay, fine. So current thread is main anyway. So I'm just using the main thread itself. Now, as I said, if you want, you can even change the name by using this t dot set name. Like this, you can even use the name, and you can give some name of your choice. Let me just give the name as I'm just giving my name, and let me use this same statement and see whether the name got changed or not. And so I'm just modifying the current thread name. Fine. The thread name is getting changed. This is how you can even change the thread name, and even you can even check for whether this particular thread is alive or not. Also, all that you can even check by just using like okay, sys out t dot. So here you can see is alive. So is alive, is daemon, is interrupted. You can see, and this is how even when you are developing applications, you need to remember whenever you are writing any method that will be returning boolean, always make sure that the method will be something like a question category. Here you can see is alive, it's like question. Is daemon, it's like a question. Is interrupted, it's like a question. So you need to keep this in mind. So even when you are developing applications, just remember the fact that when you are writing any methods that will be returning boolean, just try to use something like this is prefixed to the method name which you wanted to. So this will return boolean. It will just say whether the thread is still alive or not. Similarly, I can also use the method t dot is daemon to check whether this particular thread is daemon or not. And similarly, I can also check if this particular method got interrupted or not. Something like this. You can just check all these things. So just try and explore how each and every method is behaving, because you don't know what you will be asked in the exams. So here you can see true. That means the thread is alive. It's not dead. And is it a daemon thread? False. And is it interrupted? No, it is active and it is running. It's not interrupted. That's what here you can see. And similarly, you can also get the priority value. Here you can see by using the get priority, you can even get the priority value. So by default, it will be returning 5. As you can see, by default, we already said the default priority value is always 5. And suppose if you want to set your own priority, you can even set. Here you can see t dot set priority. So you can see t dot set priority. By using this method, I can give my own value, and the value you can give directly from 1 to 10, or and after this, once again, let's print this priority value. Here you can see, and so first I am returning the original priority, and then I am modifying the priority. So here you can see first it has displayed me the priority value 5, and after by using the set priority I am setting the value to 8, and when I am returning that value, you can see 8 is being returned. And this is how you can do. And similarly, you can even set this particular thread. I mean, if you are interested to make this thread a daemon thread also, you can do by just using t dot. Here you can see set daemon, and here you can write here you can see true. So by just setting like this, you are going to make this thread as daemon thread. You are making this thread as daemon thread. And after this, if you ask it, after this if you ask it, definitely it's going to return true, because we are setting it true. So definitely it will return true. Okay, illegal thread state exception. Yeah, as we know that I hope you can understand this, because main I can't set it as daemon. because main is the one which is responsible for the entire application start and execution. So main I can't set it daemon. Just for showing you I have written. I expected this exception. So don't set main thread any time daemon. If it is any other child thread, you can do that. And but just understand, by using that set daemon of true, you can set any thread as daemon thread apart from the main thread. And then even you can invoke, here you can see t dot destroy, and you also have okay, let's destroy it. And then, so don't worry, it's a deprecated method. That's what it will give this strike and text. So destroy is a deprecated method. That means with the present version, destroy is being overridden by some other method. That's the reason it just comes with strike and text. You can just add this annotation to the main method so that no deprecated warnings will be shown. So if you just click this quick fix, you don't see that. And suppress warnings, deprecations, automatically that warning will go off. And then if I just try to execute this, so here you can see after destroying, okay, main again the same thing. Actually it should come true, but I already said for main I am not supposed to use this. But just remember that by using destroy, you can just destroy the thread, and after that if you just check the is alive, you will be getting the answer false, because main will be destroyed now. So that's the reason you will be getting that. But here main I am not supposed to destroy it like that voluntarily, so that's the reason you are getting that particular error. So I hope you understood how to set the priorities and how to get the priorities. And there are several other methods which you can execute as part of that. So just try to observe all that. And there are other thread control mechanisms which we need to cover. So as part of the thread control mechanisms, you need to understand that we will be using two methods. That is the join method you will be using. So join method, the main purpose of join method is the thread which invokes this join will be waiting until the thread on which it called terminates. So this is the definition of join. So whenever a thread, like I mean here you can see t dot join, but anyway this cannot be joined because this is the only thing. Okay. So join comes with interrupted exception. Join comes with interrupted exception. So for that reason it is giving me quick fix. Either declare throws or surround with try catch. If I declare with throws, by default it gets added to the main method. Here you can see main gets added with the interrupted exception. And suppose if I choose surround with the try catch, this particular statement will be surrounded like this, because join method again from the thread class is coming with declaration throws interrupted exception, just like as we have shown sleep method. Similar to sleep method, join also comes with the declaration throws interrupted exception. So whoever is going to call this join method, it is their responsibility to handle the interrupted exception. So that's the reason here you can see. And as I said, the join method is mainly meant for asking the thread to keep waiting until the child thread terminates. So that's the advantage with the join method, and this is how you will be using the thread control mechanisms. And even here instead of using this set priority of directly value, you can even use this here you can see max priority. Like this you can use thread dot max priority -2. This is nothing but 8 only again. You can directly use integer value if you are okay. Otherwise you can also use like this, thread dot max priority minus 2, or thread dot min priority, which will be plus 1, so plus 7, which is nothing but again 8 only. Or you can also use thread dot norm priority plus 3, which is again nothing but 8 only. So these are the different ways of using. So these are the constants, these are the constants. Thread dot, here you can see the description, norm priority 5. When I am using min priority, it will show 1. When I am using max priority, it will show the value 10. So this is also the other way how you can use this. And even you can just see, if I am giving 18, so if I am giving 18 also, it will not raise any error. But when you retrieve the get priority value, you can see what is happening. So compile time, it's not raising any exception, but it is saying illegal argument exception, because you can't give any value other than 1 to 10. You can't give any value other than 1 to 10. So just remember that compile time, it will not raise any exception. So this is with regard to the multi-threading, that all you need to remember. So we have covered this creating threads with runnable interface and creating multiple threads, creating threads by extending thread class. Yes, we have seen. And thread control mechanism, just now I said. So thread control mechanism is basically understanding the join and isAlive methods. So isAlive will return false if it is not alive. It will return true if it is still alive. That's what the isAlive method meant for. So it returns true if the thread is still active. It returns false if the thread is destroyed. And similarly, you can also see join method. Join is waiting until the thread on which it is called gets terminated. So that's what the join is meant for. And thread priorities, as I have already given the theoretical description, it's only meant for knowing which thread has to be given more time and which thread has to be chosen when multiple threads are waiting for CPU, and the value can be only between 1 to 10. So that's all you need to remember. And coming to synchronization, so it's the very last concept of multi-threading. So thread synchronization. What is synchronization and why do you need to provide this synchronization? So synchronizing is nothing but, since we have already understood that threads belong to the same application, and when you have threads sharing the address space of the process to which they belong to, and they share the data of the same process, and we also understood that thread based multitasking means single program running concurrently. That's nothing but multiple threads of same process executing concurrently. So when you have this situation where multiple threads of same process executing concurrently, which share the same data of the process, then if two threads try to modify the same data at same time, then it leads to data inconsistency. So for that reason, it's important to make sure that we need to protect this data being modified by multiple threads at same time. So for that we need to synchronize. We need to synchronize the shareable resources being accessed by multiple threads at same time. So the shareable resources need to be protected by being accessed at the same time. And that's what thread synchronization is all about. And in Java, it is very simple mechanism by just making the method prefixed by the keyword synchronized. synchronized, synchronized. So by simply using the keyword synchronized before the method declaration, you automatically make that method synchronization. That's nothing but when multiple threads try to execute that method which is declared to be synchronized, the one which first gets control over that method will immediately acquire lock so that other methods who wish to execute the same method cannot execute because the lock is not available. You can just understand in that manner that if a method is declared as synchronized, then you can just treat it like some locking mechanism. The very first thread that gets access to this method will acquire the lock, and until it finishes that method and leaves, it's not going to release the lock. And the other threads who also wish to execute the same synchronized method with no lock available, they have to be kept waiting. They will be kept waiting. They don't have any other option. They don't have any other option. So that's what the synchronized keyword of Java will ensures thread synchronization. So it's very simple. Whatever the general code you are writing, it doesn't change anything. So whatever the general code you write it as it is. And if you are sure that your method contains the code which is accessed by more than one thread, then automatically just add the keyword synchronized. Just prefix your method declaration with the keyword synchronized so that if multiple threads are being created also, only one thread can successfully gain access over this particular method and perform the alteration to the shareable data. That is what the thread synchronization will be performing. And in Java, it is very simple by just prefixing the method with the keyword synchronized. That is synchronized. By simply using this keyword, you can just synchronize the method. And here you are given a simple account withdraw method as an example. You can easily understand that. So you know account withdraw mechanism. So if two people from two different places try to withdraw the amount, so what has to be done? We know that only at one place first withdrawal should be successful, the other place it should be only after that. So for that reason, here you can see this particular method withdraw is being prefixed with the keyword synchronized. This withdraw method is prefixed with the keyword synchronized so that the very first thread who wish to perform this withdraw method will be successfully executing until it completes withdrawing and updates the balance. Until it completes withdrawing and updates the balance, all the other threads who wish to perform this withdraw method will be blocked. Will be blocked. And that's what I said. Wait, notify, all those things comes into picture. So whenever the thread gets blocked due to which it doesn't have the lock free, and whenever this first thread completes, then the other threads who wish to perform the same withdraw operation will be notified saying that lock is available now, so you can proceed with your operation. So this is how synchronized keyword in Java will easily perform synchronization. You don't need any additional mechanism for this. And this is what about thread synchronization. So with this, I'll just put full stop to this multi-threading concept. And I hope all of you have gone through the message posted by Madam and Ali sir also in the group. So it is fixed that your exam will be on Friday. So on Friday, generally the links will be coming from 9 a.m. But we will try to see if it can be given from 10 a.m. access, and you will be taking the test from your own laptops, and it's time bound. And just make sure that you are going to clear all the test cases of the logic building exercise, and I have been receiving since yesterday from many people saying that few of the solutions they are not able to get, but individually I can't give answers to everyone. So that's the reason I asked, is there any logic building exercise that you wish me to help on a general note? But not many of you have responded to that. But individually, it's quite difficult for me to give answer or explain how to perform all that. That's the reason whichever I felt little tough for majority, I have just given that. And surprisingly, few of them have asked me how to perform the hill pattern also. I have already opened the logic building exercises here. This is from M1. This is from the logic building our plan M1, and this is M2A, and this is from M2B. And I already said that try completing M1 and M1A. M2B we don't know. First thing is we are not sure which kind of logic building problem they are going to ask you for this particular assessment milestone, and that's the reason I have asked you to complete up to M2A. I don't know how many of you have successfully completed, and few of them were asking me personally saying that one or two test cases are not getting processed, but when I am executing in my IDE I am able to see all the possible inputs I am giving, I am getting it correct. That's what you need to understand. Your IDE you will be giving the test cases which you expect that you will be getting it correct only, but the server side what they are going to give is the failure test cases also they will be giving, in which your logic should not return any result. In that way you have to think and write logic, and if you fail in writing not only meeting that successful test cases, you also need to write your code which will also include the failure test cases. In such a way you need to write, and no way you can give complaint or you can tell that some of the test cases are not getting passed means there is something wrong with the particular uh, mechanism, because all the problems given here will pass all the test cases. If one or two test cases you are not able to pass and you are damn sure that your code is correct, no, there is some minute logic mistake which you are doing, due to which your code is not passing through all the test cases. So remember the fact that all the test cases must and should be passed in order to get full marks for the logic building exercise. And since I have received three of them stating this generating pin, okay, that's from the first one, that is from M1. So far I have received three people asking me they are not able to pass through this creating pin using alpha, beta, gamma test cases. So I would like to just run my code and show how it gets executed all the test cases. And if you have your own logic and you have already successfully implemented by creating the pin using these three numbers, that's fine, well and good. For those who have not successfully done, because as I said, three of them yesterday itself personally have asked me that they are not able to pass through a few test cases, and for that reason I'm just quickly I'll show you creating pin. And surprisingly I have even received query saying that hill pattern also not passing few of the test cases. Hill pattern is very small logic, just requires 5 lines of code. I mean, according to me I have just written in 5 lines of code, but even if you are not able to solve that, it's really, and I'm just giving some, I already said just you need to give unique mail id, rest everything you can give. Only mail id has to be unique, rest of the fields you can have it same. So click on end tour. So So creating a pin using three given input numbers, and the advantage with this question is we are already given clearly stating that the three input numbers will be ranging between 100 to 999. That means it is evidence that it is a three digit number. It is clear that whatever the inputs given are going to be three digit number. So when you are sure that they are three digit number, I don't think you should feel any complicated to find the units place and tens place and hundreds place from all the three numbers. And what I have done is I have taken three arrays for units, tens and hundreds. I have taken three arrays for units, tens and hundreds, and then I have acquired all the unit digits from all the three numbers and stored in units array, and all the tens place digit from all the three numbers and stored in a tens array, and all the hundreds digit from all the three numbers and stored in a hundreds array. And then simply I have passed this array to a function called min function. I have written my own function min function, and then I have called min function which will return me the minimum among these units, tens and hundreds, so that I will be getting three values: the minimum among units, the minimum among tens, the minimum among hundreds. And then one more digit we require, that is the largest digit among all three numbers. We need to also find the largest digit among all three numbers. So if you get the largest digit among all three numbers, then you can just write the equation, that is the largest digit into 1000 plus the minimum of hundreds digit into 100 plus the minimum of tens digit into 10 plus the minimum of units digit. That is how you get the end result. It's very simple, but still few of them are not able to pass through all the test cases. For that reason, I'm just okay. So these are all the logic building problems which I have solved during my training session. So you don't require any reading of inputs. This is only from your desktop system. When you wanted to run, you require. And you don't require one brace. Okay, more. So instead of system.out.println, you just need to replace it with the return statement. I'll just tell what I have done. Just a second, because it's been a long time. Okay, it's working fine. So let me just tell my logic. So here you can see these are the three input numbers which they are providing you as the arguments with the input. Now what I have done is I have just taken these three inputs into an array, so that I am not going to write separately for extracting the tens digit, hundreds digit, units digit from each and every number separately. For that I have just stored all these three numbers into an array. And why I have taken this B array is, this B array I have initialized it to 10, which is for indexing 0 to 9, that is to find the largest digit. And for that reason I have just taken this, and these are all the variables which you will understand for which purpose I have taken. And here, as I said, since there are three numbers, I have created units array with the size 3, similarly hundreds array with size 3, tens array with size 3, units, hundreds and tens. That's what these three arrays are meant for. And here this for loop you can see I am running it 3 times because I have 3 input numbers, and here you can see each time it's going to get me. That means u of 0, t of 0 and h of 0 will be uh, containing the units, tens and hundreds of the first number. U of 1, t of 1, h of 1 will contain the units, tens and hundreds of the second number. U of 2, t of 2, h of 2 will contain units, tens and hundreds of the third number. So that's what this simply one loop will be sufficient. And next, here you can see this is the simplest logic I have just written for getting the digits. So here you can see what I have done with the B array. So while a of I greater than 0, because my A array contains all the 3 input numbers. So on each number you can just see what I am doing. A of I percentile 10. That means I am setting that particular index to 1. That means if the number is 975, assume that the number is 975. So when I am doing A of I percentile 10, what happens? Then it is going to return me 5. So index 5 I am just setting it 1. Index 5 I am setting it 1 because by default all the B array values will be 0 because it's runtime allocation and no garbage value concept. So all the B array values are 0 initially. So what I am doing is, for suppose if the first number is containing 975, I am just giving you an example. So A of I percentile 10 will return 5. So B of 5 equal to 1. That means index 5 indicates digit 5 is encountered. And then I am just dividing it by 10. So next time it will be 97. So 97 percentile 10 will return 7. So that means 7 index also I am setting it 1. Next time it will be 9. So 9 will be, index 9 also will be returning 1. And assume that second number is something like 568. 568. So first time 8. Index 8 will be set to 1. Next time 6 will be set to 1. Next time index 5 will be set to 1. So like this I am just setting the index, and that index represents the digit. That index represents the digit. And why I am doing this is because I require the largest digit among all these 3 numbers. I require the largest digit among all these 3 numbers. So for finding that I am just using this simple mechanism so that that particular index will be set to 1. And now I don't know what will be the input numbers and I don't know which index value is set to 1. For that reason I am using this for loop. Here you can see in this for loop now what is the logic I have just written. I equal to 9, I greater than or equal to 0, I minus minus. And here you have to understand, you can also check it from 0 to 9, but that doesn't make sense because your intention is to find the largest digit. So in order to find the largest digit you have to do it in reverse so that you can just break the loop immediately. And if B of I equal to 1, that means if B of 9 is 1, that means among the 3 numbers there is a digit 9. So I'm just saying max equal to 9 and I'm just coming out of this loop. This will improve my performance. This will improve my performance. So this is how I'm just finding the largest digit among all 3 numbers. And next here you can see simplest logic, which I already said. X equal to minimum of units, Y equal to minimum of tens, Z equal to minimum of hundreds, and my min logic will return that minimum value. My minimum function will return that minimum value. And once I got this minimum of units into X, minimum of tens to Y, minimum of hundreds to Z, my task is simple. By just using this statement, result equal to maximum among all the 3 numbers, that is the largest digit among all 3 numbers, into 1000 plus Z, which is my minimum of hundreds, into 100 plus Y into 10, which is my minimum of tens, and lastly X, which is my minimum of units. And then I'm just returning this particular result by using this return. It's very simplest logic. And since one of them asked me generate hill pattern very quickly, because these are the 2 which I received yesterday. For that reason I am just showing. Just a minute. So here you can see 3 inputs, and the question, I don't know whether you people remembered or not. Most of you might have executed. If not, I'm just telling. So hill pattern means you already know the first level 1, next to 2, next to 3, next to 4, next to 5, like that. Suppose if the first itself is containing 4, then next to 5, next to 6, next to 7, next to 8, next to 9, so on, like that. So input 1 represents the number of levels. Input 1 represents the number of levels. Input 2 represents the starting weight. Input 2 represents the starting weight. And input 3 represents the sum factor. Input 3 represents the sum factor. That means suppose if the input 3 is 2, input 2 is 10, input 1 is 4. You can just go through that particular once again there. Okay, let me just click on this finish. So in the end exam also, this is how you will be getting the same metal platform but with a different problem statements, and you can download the report and see also even for the thing. Let me just click back, and here yeah, here weight of hill pattern. So hill pattern, if you just click on this link and go through the question, you will understand. So it just contains 3 inputs. As I said, the first input contains the number of levels, the second input contains the weight of the starting level, input 3 contains the incrementer weight for each level. That means, as I said, for suppose input 1 is saying 5, input 2 is 10, input 3 is 2, then what you have to understand is the first level contains 10 as the weight, the next level the value should be 12 because input 3 is 2 na. Since input 3 is 2, the second level it should be 12, and the next level it should be 14, the next level it should be 16. And since the levels are given 5, I mean input 1 is given 5, you need to do it up to 5 levels. So for that reason, it's very simplest logic. Here you can see, you can just do this simple logic. So sum being initialized to the initial weight, that is the input 2, and a temporary variable which I have taken to just store this initial weight only. And here in this for loop you can see I am running this up to the input 1 times. I am running this up to the input 1 times. That means how many levels is given in input 1 na. So for that reason I am just running this for input 1 times, and here you can see I am just doing it by adding the input 3. I said now input 3 is the incrementer. So for that reason I am just doing that. And here you can see sum which is initialized with the first level weight, which is the input 2, and each time what we have to do, for the first level you will be having 1, second level 2 times, third level 3 times, fourth level 4 times, fifth level 5 times, so on like that na. So for that reason we have taken j loop, which is running up to j less than or equal to I, and then sum is being added to the temp, and where temp is each time whenever I is being repeated na, for each level temp is being added by the incrementer value, which is the input 3. So this is how I have used my logic, and I hope everyone can easily understand this, because initial weight, that is input 2, set to the sum value, and then each time the for loop is I loop is running, I am just adding the incrementer, that is input 3, and j loop is going to run up to I times by adding that temporary value which is containing the incrementer. And this is how you are just adding, and here you can just replace this system.out.println with return. So this is how you can just do. And for this Wipro kind assessments, you can just write your code to make sure that all the test cases get passed, but you need to practice more and more, not only to pass through the test cases, also to get the time of execution very less, because as you go further, definitely you will be encountering situations where even the execution time will be restricted, because I have already shown you while explaining the JUnit. So the timeout value also matters. So just make sure that not just running through the test cases, but also you will try to optimize the code to make sure that the timeout value will not be exceeded. So it's been 12 o'clock anyway. Let's stop it here. And I need to start with RDBMS, SQL, and JDBC. And I would like to start that after your assessment. So for that reason, tomorrow I'll give a quick recap for the assessment milestone 1 only, so that after your assessment milestone 1 exam completes, I'll just start this RDBMS, SQL, and JDBC concepts, because with that again we will be ready even for the assessment milestone 2. So I don't want to move so quick that I will even cross the topics after milestone 2 also. For that reason, I'm not going to start RDBMS, SQL, JDBC tomorrow. So tomorrow I'll just give a quick recap with all the concepts so far I have discussed. I'll just give a few overview for the assessment milestone exam which is scheduled on Friday. And as I said, Thursday I'm not going to take any class. I'll just leave it for your preparation. Friday you have your exam. Again Monday I'll start this RDBMS, SQL, JDBC. So with this I'll just stop. You can start posting your attendance in the comment section. Okay, I hope all of you have given your attendance. Let's stop for today and let's meet for tomorrow's recap session for your assessment milestone 1. Thank you.